Hello, today's video is going to talk about solving rational equations. So there are two methods for solving rational equations. The first one is when you can make it into a proportion. So that would be one fraction equals another fraction. And then the second method is using an LCD, and we're going to look at that in some examples. But it says to always remember to check your solutions, and to do that, we want to make sure that the solutions do not make any of the denominators equal to 0. So the first example, number 1, we're going to use method number 1. Only two fractions so they can be set equal to each other. That is, those are proportions. So when we have this, we can just cross multiply and solve for x. So we're going to multiply 7 times x, and that will be equal to these. I'm going to put the 4 in front because it's a coefficient. So 7x equals 4x minus 24. Subtract 4x from both sides, and we get 3x equals negative 24. Divide by 3, and x equals negative 8. Then we want to check. If we plug negative 8 into here, will we get 0? No. Here, no. So that is good, and x equals negative 8 is our answer. So I'm only going to do one more example of this method because I think that you guys will catch on to this one really quickly. But in this case, we're going to end up having a quadratic equation to solve, and I just want to do a quick reminder on those. So when we cross multiply, we're going to have y times y plus 5 equals 3 times y plus 8. So when we distribute, we'll get y squared plus 5y equals 3y plus 24. And then anytime you have a squared in there, that means it's a quadratic equation. So when we have quadratic equations, we want it to equal 0. So we want to pull everything to one side. So I'm going to subtract 3y and subtract 24. And that 24 is kind of going to be off by itself. So when we do that, we're going to get y squared plus 2y minus 24 equals 0. Then we want to factor this. So remember, when we factor, we want things that multiply to get negative 24 and add to get 2. So we are going to get y plus 6 times y minus 4 equals 0. Then we set each one equal to 0 and solve. All right, so then we have to make sure there's only one denominator with a variable in it. Do either of these make this equal 0? No, they do not. So they are both valid answers. And the reason that the denominator can't equal 0 is because you can't divide by 0 in math. And then the second type, in the second method, we multiply everything by the least common denominator. So I'm going to show you what that looks, or why we do that and what that does to our problem. So we have 3n and 6. So our LCD is going to be 6n. And all three of these go into 6n an even number of times. So we are going to multiply every single part of this by 6n. And I just kind of write it like this whenever I'm writing it out. And when you multiply by 6n, it's 6n over 1. So you're only multiplying the numerators. And so 6n times 4 is 24n, and we keep the 3 the same. 7 times 6n is 42n over n. And then 1 times 6n is 6n. Well, now all three of these are going to simplify to not be a fraction anymore. So this one simplifies to 8n. Then we have minus 42 equals n. And now it's just an equation that we can solve. So we're going to get negative 42 equals negative 7n, and then divide by negative 7 to get n equals 6. Then we check up here to make sure that that does not set any of the denominators equal to 0, and it does not. So n equals 6 is an answer for this problem. All right, this is the last example I'm going to do for you guys. This one is a little bit more in depth. These are kind of the harder ones you're going to have. So the first thing that we need to do is we need to factor this denominator to be p plus 2 times p minus 2. And obviously the 2 is over 1. So our LCD for this one is p plus 2 times p minus 2. So we are going to take each numerator and multiply it by the LCD. So I think until you get lots and lots of practice, you should write this out every time. So p times p plus 2 times p minus 2 all over p minus 2 plus 2 times p plus 2 p minus 2. And that's just over 1, so I'm not even going to bother with that. Equals 8 times p plus 2p minus 2. And then I'm going to keep the denominator in factored form so that we can cancel stuff easily. So now that we have this, we want to cancel everything that we can in each term. So p minus 2s are going to go away, and then both of these will go away. So now let's rewrite what we have left. We have p times p plus 2 plus 2 times all of that equals 8. So now we need to just simplify all of this and solve. So we're going to get p squared plus 2p plus, I'm going to multiply these first because I already know what that equals. So 2 times p squared minus 4 equals 8. So then let's bring it over here. We're going to get p squared plus 2p plus 2p squared minus 8 equals 8. And then we've got these squared, so that's going to be a quadratic function, so we're going to bring everything to the same side. So we'll have 3p squared plus 2p, and then I'm going to subtract 8 from both sides, and we'll get minus 16 equals 0. So now we are ready to factor. I'm going to do a quick refresher on the x method because that is occurring a lot in these examples. So to factor with the x method, we make an x, and we do 3 times negative 16. So I call that a times c, and that's going to be negative 48. And then b goes down here, that is positive 2, and we want to multiply to get the top, add to get the bottom. So I'm going to choose positive 8 and negative 6. Then we bring this term down. We bring this guy down and put a p on it. We use these two terms to make to split the middle term. So then bring your c term down. Then we split it down the middle and take the greatest common factor of each side. So p times 3p plus 8. And we always keep this sign, minus 2, 3p plus 8. And then these are the same, so that's one factor. And then this guy and this guy make up the other one, so p minus 2. All right, so that's all equal to 0. Now we have to set each factor equal to 0. And we're going to get p equals 2 and p equals negative 8/3. And then we have to check those. So we go way back here to our original problem, and we see if either of these values make the denominator equal 0. Well, if we plug 2 in here, that's going to equal 0, and that's not allowed. So 2 is an extraneous solution. And if we plug negative 8/3 in, it does not give us 0 in either denominator. So this one is good. So only p equals negative 8/3 is our answer. And if both of those were extraneous, then it would just be no solution. All right, that's all for today. Good luck on the worksheets. Let me know if you have any questions. Hope you guys have a good day.